Okay, hello, hi everybody. Like the slide says, my name is Duncavage, and I'm a software principal at Rdio. And I work mainly on the Android app, but since we use Xamarin, I kind of touch indirectly the iOS app. So I'm here to talk about Android today, and specifically how to get your app nice and smooth, and be like the butter. And I mean that in like every sense. Like your app should be consistent, smooth, frictionless. Should let the users get to where they need to get to easily. And there's a few ways you can ensure that your app does that. But first, why is scrolling important? Because users love to scroll. Like think about what app have you used that's not a game that didn't have some level of scrolling in it. It's the way that you're going to display a potentially infinite list of items to the user, and it's largely the main interaction the user has. So we should make sure that we don't have any jank, because it breaks the illusion. Like we're writing native apps, right? That's the beauty of using Xamarin. We're writing native apps. We're not like a web wrapper or anything like that. So, and they're awesome. So let's make sure that we're leveraging the native app to be as smooth as possible. Because if janky scrolling, if the user is gonna perceive that even on a subconscious level, that your app's gonna feel unpolished, it's gonna feel a little cheap, and it'll feel like a web app, which we're not building those. So yeah, so let's how do we figure out the best way to ensure this buttery smooth scrolling? So yeah, we're the pixel pushers. We're the ones putting the pixels on the screen, right? We're writing the UI. It's the most important part of the application as far as the user is concerned. So what can we do to identify once you've written your app? This is all things to do after you've designed, you've written your app. You're going to go back through. I mean, you should be thinking about these things once you know them as you're building your app. But some of these techniques you can go back and refactor, and you can use the tools to find issues. One of them is using the platform profiler, the one that comes with the Android SDK. And I'll show you a demo of that later, just a quick example of how to use that. And you should follow established design patterns. There's a few things that you can do when you're designing your layout, or you're implementing your layout, when you're returning views from your adapter's GetView method. There's a few things you can do that are best practices that you can do to really squeeze as much performance out as you can. And then lastly, managing bitmaps, which is not purely just for scrolling, but a lot of times you're showing a list of images, so it's important, and I'll get to that towards the end. But first, let's get into using the profiler, and this is the standard profiler that is in the platform distribution, the Android SDK. It's in the tools directory. It's part of the monitor package. If you haven't used it, you can, and it works with Xamarin apps just like any other native app. So how you use it is, if you're noticing that you're scrolling, maybe while you're scrolling slowly, and when a new item comes on screen, maybe instead of it coming up nice and smooth, it comes up a little, boop, and you maybe drop a few frames there. And you want to figure out why is that happening. So what you do is you profile your application, you just use it, just scroll. And the method profile you'll be able to see on a graph the methods that are taking longer than usual or longer than they should, and will cause you to drop a frame, because all that stuff is happening on the main thread, and it has to, because that's where all the UI rendering happens. So you have to make sure the main thread is clear for rendering to happen, but you have to deliver the views on the main thread as well. So you got to make sure you're being as efficient as possible. So I'll do a quick demo of the where am I? Okay, here. So I have a special build of the Android or the Rdio app that should have janky scrolling. I had to add a rather terrible thing to the GetView method to get it to show up on the emulator here, but for this thing to deploy. Okay. All right, so we're in this trending section. It shows popular things that from people you're following. But you're going to scroll through just a nice grid here, but you can kind of see that there. Like, see, it seems like it's dropping some frames. Like that should be a really smooth animation, but it's just not. You can kind of see how even when it's decelerating, it's kind of getting a little slow, or it's kind of dropping some frames there. So what you do is you take out monitor, you select your process, fire up the profiler, and then do some more scrolling, and then just come back. And I know this is kind of hard to see on that screen, but I'll try to zoom in on this area here. These big blocks of blue, I decided to use a really hard color to see. But if you look here, these things are taking a long time. That's how long that method's taking, from here to here. And that's definitely long enough to drop more than one frame. Because if you want to get 60 frames a second, you need to be taking no longer than 17 milliseconds per cycle to hit that frame rate. So you always want to try to be as close as possible. So right now we're not. This is definitely, something's happening here. But I can see that, and I know this is kind of hard to see too, but you can see up here that there's my header grid view, fixed grid view adapter, GetView, is taking too long. So I can go look at that here. So this is our own special custom adapter. We have a thing called populate view, but you can consider it GetView. So now I just realized, oh, wait a minute, I have some long-running thing here before I finish either creating a new view and configuring it and returning it. So let's just see what happens when I get rid of it. We should hopefully see a better improvement, and then we'll run the profiler again to prove to ourselves for sanity that we actually did reduce the amount of time that method takes to return. Yeah. It's the app building itself right now. It just happens over there. All right. Loading. Okay, so now let's see. It's kind of hard to see there, but see, it's nice. It's decelerating nicely. There's no going up and down here. Seems really nice. But let's run the profiler just to make ourselves honest here. Select the process. Start the profiler. Just do some scrolling. Stop it, and then if you go here, look here. You can't even really see all these are just more like framework stuff that's happening. I'm trying to find. So you can't even. It's even hard to find it now. How long that method call is taking to finish. It's got to be somewhere in here. Oh, there we go. So now it's only taking. It's at 10 milliseconds total. And before it was taking something like, I don't know, 100. So now we know that we've optimized that method. So let me get back into the slides here. So we found out that our GetView was taking way too long. We went in, we figured out, we're doing something long running. And if you find out that the long-running thing that you have in GetView, that you need it, you need to think about a way to not do it there. You shouldn't be doing, when you're scrolling and you're doing GetView, you shouldn't be doing anything like making a database call or anything like that. That data should already be there. There should be something else, maybe feeding data into the adapter, and you can always increase the size of the items that are in the adapter. But you shouldn't be doing that as you're getting new thing, as you're just returning views, because you want to do that as fast as possible. And then I just have a couple notes of things that I have found personally when I've been trying to get the app smoothly scrolling, the Rdio app. That image view calls request layout when its drawable changes and it has new bounds. So, and if you notice in our app, while the image is loading, we have a little placeholder, like a gray square. So we're swapping a drawable out there. And the thing, we were just using a plain old just color drawable. So we'd have to set the drawable on the image view, which implicitly, image view, the image view.java, if you check, when you set the drawable, the color drawable has no intrinsic bounds, right? It's just a color. So it says, well, I need to request layout because my bounds are changing. That can be really expensive because your list view, your item is going to request a layout, which causes basically everybody else in the hierarchy to want to relay out because it might need to, because it doesn't know if the bounds have changed. So one thing is to use a placeholder that has defined bounds. But if you don't know what the bounds are going to be at runtime, you can use a somewhat hacky method, but it does work. If you know that you're going to be showing, like in this grid, the images are always the same size. So you can have your own custom image view subclass that just ignores request layout if you have a fixed size image. And it does work. And if you know that the image isn't going to change sizes, then you can do that. And that's kind of a little tricky workaround. So, all right, the next thing, further optimization. This is like the best practices. The view holder pattern. I don't know if you guys learned that in the training, but it mitigates the calls to find view by ID, which they can be fast, but depending on the complexity of your view hierarchy, if you have a lot of nested view groups, which you shouldn't, but if you do, and then you're calling find view by ID on the root view, it's going to have to traverse the entire hierarchy to find that view in it, and it can be slow. So you just shouldn't do it in GetView. You're going to probably have to do it once when you create the instance of the view, but after that, you shouldn't do it again. But on top of that optimization, it also encapsulates your view operations. So you're starting to define an API for the view. Like in our app, we have this list item view class that we use all over the place because we want to have consistency and reusability. So we have, rather than just using a view holder, you can evolve that into a custom view, which is pretty easy to do. And I have an example of that I'll show. And always keep the main thread flowing. Try to just always offload work to background threads where you can do it. Just be as fast as possible. And then be smart with your layouts. I mean, the general rule is never use relative layout. Most people say never use it. There's some exceptions to that, but generally never use it in a list view, because its measurement process is the most expensive because it has to measure and measure twice and then request because it's laying things out relative. So it has to first figure out how big everything is and then figure out where everything sits on top. So it's just really slow. It's probably the easiest layout to use because you can just say this is to the left of this is to the right of that, but it's slow. And then you should always avoid nested view groups, just because you're adding, another whole, like if you have 3 nested groups and the furthest child requests a layout, all the rest of them are going to request layout as well. So try not to do that. You can get away with frame layout a lot, even though the documentation says because it doesn't guarantee that things don't overlap, but sometimes you want things to overlap. And it also has gravity, so you can put things at the top or the bottom or the left or the right, and it's super fast because it's not actually depending on where other things are in the view to figure out where to draw things. Okay, so here's the view holder. I'll just go through this real quick because it sounds like you guys maybe already saw this, but basically it's just a simple object that you have, this would have a title and an image property. When you create it, you give it the root view, it'll find view by ID on it, and then hang on to those references. And then in your adapter, you would just say, because how if you're familiar with how adapters work, your convert view is the view that the list view wants you to recycle, right? If you have 100 items in your list, you're not going to have 100 views, right? You're going to have the number of views that the list view can currently display. So if the windows can show 5, it's going to have 5 views, give or take. It might do one below and one above. Once one goes off, you're scrolling up, one goes off this way, it's going to give that back to your adapter, and you can reconfigure it. So you should only ever be creating instances in here if your convert view is null. This also cuts down on allocations, which will cut down on GC cycles. So what you do is you inflate your view, you give it to the view holder, which the constructor for that view holder does the find view by ID, and then you set the properties on it. And then the next time around, when you get a view to recycle, all you have to do is find it in the tag. You just kind of stash it in there, and then you can pull it out and just set it. So that way, this is really fast because you're not find view by, you're not calling new, and you're not calling find view by ID all the time. So the evolution of this would be to make a custom list item view, and this is just a nice thing to, because you can start reusing this everywhere where you have a certain consistent list item. So this is like taking that previous view holder and turning it into a custom view. So in this case, I have my custom view as a frame layout, and then I'm just going to give it a context and a layout resource ID to inflate itself from. And so this is like a performance increase or improvement, because if you look, I'll show you the stub for the layout for this thing. But what it's doing here is it's inflating the view, and then it gives itself as the root, and then it says attached to root. So the thing that is getting inflated, it will attach it. This view becomes the root view group for that inflated layout. And then I'll show you, so it'll make sense when I show the layout. And so then it does the same thing, and this basically does the same thing the view holder was doing. It just finds references to the views that it cares about, and then I specifically made like a set title property, because maybe you want to use encapsulation, you want to control access to the properties, because maybe this view like always, camel cases the title or something like that. You could put that in here, and then everywhere, you could just call set title past the string, and it does whatever processing it needs to do. So then here's the example of the layout. The thing, I don't know if they taught you this, but the merge tag can be really useful, because you have to have one root element. So you can't have just a layout with an image view and a text view that aren't grouped in a single view group. It doesn't let you do that. So it would be perfectly fine to make this a frame layout, but then when you inflate it into your custom view is a frame layout. So now your custom view has one child that's a frame layout that has those things. So it's like not efficient. The merge tag lets you get past the restrictions of the layout format, so you have this one root element that has all of your other children. And then when you inflate the layout, you have to give it that. That's why that view is passing itself in as the root view, and then telling it, yes, I want to attach this. So then this just becomes part of that custom view, and you're not adding any unnecessary nested view groups. Okay, so that was a bit of a crash course in that stuff. But so we'll get to bitmap caching. It's a complicated topic, but it makes sense, right? Because images are everywhere, right? If your app doesn't have a lot of images in it, it doesn't look very exciting. So this is like a little crappy movie I made, I guess, of our new home section in the Rdio app. And you see there's lots of images, lots of different sized images, different kind. And the thing is, like, once we load it once, we don't want to load it again. Like you've already downloaded those bytes. Try not to download them again if you can help it, because if you're scrolling, the user might be on item 0 and then go to item 50, and you go back to item 0. You want to have that thing ready for them right away. And the way to do that is to cache the bitmap. And you also don't want to call bitmap factory decode. I mean, you have to at some point, but you want to try to mitigate your calls to it. Like bitmap factory decode is where you're going to get the dreaded OOM. Like, I don't know if any of you have ever had like an Android app that has a list of images. You probably hit OOM. And it probably happens at that point where you're calling bitmap factory decode. But that's the guy that's going to make the allocation. And bitmaps are big. An uncompressed, like if you look, like the large images in here, the ones that are almost full width, they're square. They're on this Nexus 5, they're 990 by 990, which is about 2 megabytes. So talking about 2 megabytes per, in uncompressed, and then I'll get into this later, but that's in unmanaged land, which is another problem. But so you want to call decode. It's also slow, so you should also try to only call it on a background thread. So that it avoids OM errors, yeah, and avoids GC collection cycles. If you're caching your bitmaps, you're not making allocations, and the garbage collector won't run. because the garbage collector is going to, if it runs in the middle of this, you're going to drop some frames, most likely. So, get into the basics. Yeah, so there's an API 11 of Android. They added bitmap reuse, which lets you, when you're calling bitmap factory decode and you need to decode either a byte array or a file URI or some other kind of stream, you can pass it in these bitmap options, and one of the options can be an input bitmap, which is your way of saying, hey, when you're going to decode this compressed image, use this existing bitmap allocation, and it just writes into it. So it doesn't need to allocate, if you already have, say you have a 2 megabyte allocation for a big image that is off screen, and then you have another image that's coming on screen, and you need to decode that into a bitmap. Well, the ones that's off screen, you're not using it anymore, but you can draw the new bitmap into it, So that saves you a lot because you're not making allocations, which means you're not going to get an OOM at that point. It's fast, and it's supported on API 11 and higher. And then there's a couple of rules around bitmap reuse, but I will get into that a little bit later. I also have an open source project I'll show you guys at the end that kind of implements all this stuff. But there are some special Xamarin considerations, and I know that you guys probably learned this in the training performance session, but the mono GC sees the C# bitmap object as like 32 bytes or something like that. And it doesn't know that the Java peer is like 2 megabytes. And there's no way for them to know that. So even if you don't have any references to the C# bitmap object, the system GC isn't like chomping at the bit to get rid of those things because they're so small. I mean, it's the last thing it's going to free up. It's just not going to force, you know what I mean? So those things are alive, and they have a live JNI global reference to the Java bitmap. So Dalvik, when you go to allocate another bitmap, and you have these other ones lying around in C# land, Dalvik's going to want to try to do a GC. It's going to see that there's all these live references to these bitmaps, and then it's not going to be able to collect, and then you're going to crash. So you can't use weak references. I know I've seen a lot of examples where you just put everything in a weak reference LRU cache, and then you try to let the compiler do the work, or the GC do the work of collecting things. It doesn't work for that reason. Also, it doesn't let you do bitmap reuse, because if you don't have a strong reference to the bitmap, you might want to reuse it and it could be gone. You want to have bitmaps in memory. That's what I mean by keep as many bitmaps in memory as is reasonable. If your app shows a lot of images, it makes sense that your app should use a decent amount of its resources to show those images. That's okay. You don't have to be using 0 memory. So if you keep as many in memory as possible, that allows you to not only retrieve them when you say you scrolled an image off screen and then you scroll it right back on screen. Well, you want to just have that immediately for you. But maybe you scrolled off screen and then you need to allocate a new image. Well, you just then you can use reuse. If you're keeping them in memory, just because a bitmap isn't being displayed doesn't mean that it doesn't have a useful allocation that you can reuse. So dealing with peers and managing the unmanaged. So I kind of touched on that. The C# bitmap instances have a Java peer. The C# instance keeps the Java peer alive, so the Java garbage collector won't be able to collect them. The C# runtime isn't privy to the resource use of Java objects. It's kind of the whole managed and unmanaged resource issue that kind of crops up here and there. Don't depend on weak references. I think I touched on all these. Okay, so then on partitioning your cache. When you have a cache, there's 2 main purposes for the cache. One is for caching all the bitmaps that you're currently displaying, because you have to have those in memory. So you should know that they're being displayed, because it means you can't reuse them. So you have this partition for all of your displayed bitmaps, and then you have another partition that's reusable one. So as soon as a bitmap's not being displayed by an image view anymore, you can shift it over into the reuse pool, and then when you need, say if you have a cache miss, you can at least ask for a reusable bitmap and then use that to decode your bitmap into. So that brings me, so it's kind of, I didn't want to get into the nitty gritty, but so I have this open source project called Tango and Cache, which is a silly name, but it's a fast in-memory bitmap cache. It's tested. It's been in our app for about 8 months. And we've improved it over the months. All the code was peer-reviewed before it even ever made it into our app. So I've extracted those parts out and made it a project for it. And it's on GitHub. We've tuned it based on real-world usage. And I open sourced it. It's just under an MIT license, so you can go nuts. But it's important to note what it's not. So this isn't like a one-stop. I mean, maybe someday if it maybe gets built out, but it's not a one-stop like, oh, it's going to solve all your image problems. It's not a disk cache. That would be nice to have. And it's not an image downloader, so it's not a way of just saying, hey, give me this image, and cache it to disk, and then also put it in memory, and then do everything. It's just the memory portion of it. But the GitHub project has an example, a sample app with it that shows some basic usage of downloading images, sticking them in the cache, and then getting them out when you need them. The one thing I need to add is showing how to use the cache to get reusable bitmaps. So if you have a cache miss, you would then ask if you ask the cache to give me an image for a key, and it returned null, then you would want to ask it for, well, give me a reusable bitmap, and then you give it the size of the allocation you want, and it tries to find one for you. And then you would use that as an input to the bitmap factory. So that's the end. I didn't go long, that's good. So yeah, that's kind of just like a touch on some things that you can do that I've found that really help a lot in making sure that your app is scrolling as smoothly as possible. So leverage the platform tools, leverage the design patterns, and then give the bitmap cache a try. If you already are downloading images somehow, like it's easy to integrate this cache into your app. So that's the end. Thanks. I think we'll do questions as soon as she gets the microphone to you.
Have you tried the universal image loader before you decided to write your own cache?
The universal what?
Universal image loader is also an open source component for this task?
So I wrote my own because we had already written, we have an image store that, our own image store that does, like, handles image requests, has a request queue, has threads that service that queue, does the disk caching, and then we just had a simple LRU cache on top of that. So just for integration purposes, it was easier to just go in and write our own thing that we totally understand. I'd have to look at that to see, like, some of the bitmap caching things out there still have the same problems because they don't. What the cache I wrote does is it takes into consideration all of the C# issues, where it's essentially garbage collecting itself, like for you. It holds the strong references. It knows when something is no longer being displayed, no longer cached, and been evicted, and then it counts how many bytes are being evicted in order to run the garbage collector when it needs to. Because you've, and I'd have to ask maybe John P. about this, but I've noticed even if you've called dispose on your C# bitmap, which should sever the Java reference, it still, like, Dalvik still won't collect that until you've actually collected it out of the managed land. So I don't know if that cache handles it, but we also have a totally separate one for iOS. So there wasn't any, like, shared code stuff going on there.
You just noticed iOS component. Does your Tango cache available for iOS?
It's not, because it uses Bitmap Factory and it uses Bitmap. I think Paul Betts has a Splat. I don't know if that's being maintained anymore, but.
And did you solve the same issues for iOS?
iOS, I don't really work on that app as much. iOS is a lot different, though. So they don't. It's the way images are handled is just much different. So I don't think we ever really ran into that. I think they just use the simple like weak reference LRU cache on iOS, and it seems to. Yeah, so it's just, yeah. Bitmap is like stupid. It's just like a byte array, basically. There's not a whole lot going on there.
Can you explain a bit more about reusing the bitmap? I don't understand, maybe in your context, because let's say you have image 0, you just keep it into memory and not evict it, right? Is that what you mean by reusing?
I mean by reusing, so say you have, so you had image 0, and then now you're scrolling image 10 onto the screen, and depending on like when that image scrolls off screen, if I can't remember where this happens, but in that library there's a managed image view class that does reference counting to like whenever you set image drawable, it like reference counts to make sure that it says, okay, this thing is being displayed now. Like there's a special bitmap drawable subclass that actually does the reference counting. But what I mean by reuse is a bitmap that you know isn't being displayed anymore. You can pass it. So if you've ever used Bitmap Factory, there's a few methods that are like decode file stream or decode byte array or something like that. It takes an object called bitmap options. In bitmap options, you can say, here's the input bitmap I want you to use. So basically, it's your way of saying this image this bitmap isn't going to be drawn anymore, but I want you to reuse the allocation for it and write the bytes into that. The other reuse is more like view recycling, maybe is what you're talking about, where if this image goes off screen and then you want to reuse the image view, that's the like list views do that for you. Like they deliver you a recycled view that you can then reconfigure with like a new URI you want to show or a different drawable or something like that. Does that answer your question? No.
Same size, I guess.
So that was one thing I kind of glossed over. There's API 11 introduces reuse. The restriction is that the image that allocation you want to reuse is the exact same size as the thing you want to draw into it, which works in the general case because usually you're showing images in a list of a lot of the same size. So if you have a 200 by 200 image and then you have a 200 by 200 bitmap that you want to reuse, it'll work. If they're not the same size, then it doesn't work. And then on KitKat API 19, they made it a little more flexible, and you can, as long as the allocation is larger than the bitmap you're trying to draw into it, it'll work. So if you have but it doesn't work the other way around. So if you have a big image and a bunch of little ones, then you're not going to be able to reuse any of those bitmaps. So yeah, and that's actually one of the limitations of the cache that I wrote. Which I need to fix, is that if you have a bunch of 200 by 200 images in there, you're at the high water mark. You're right there, and then you try to allocate like 1,000 by 1,000 image. You need it, and the cache will say, "Well, I don't have anything that is going to fit that." So then it's just going to try to allocate all of that memory for that image when it should evict the number of bytes it needs before allocating. You see what I mean? Like if you know that you need 10,000 bytes or whatever, it should evict all of those first. It doesn't do that yet. So if you have like a list with a bunch of different image sizes, it should work relatively well, but it works best when the images are all the same size. But that could be improved. It shouldn't be too difficult to do.
Is there a rule of thumb for the cache size?
That's a good question. If you look at the sample, I have a comment in there that kind of helps. Actually, no, that's in the README. So when you create an instance of this reusable cache, you can configure it with a high watermark, a low watermark, and a GC threshold. The high watermark is like, this is when you start evicting things, when you have this many bytes in there. The low watermark is fill up the pool until that, because if you don't have a low watermark, you'll just thrash, because you'll want to get a bitmap. There won't be anything to reuse, and then every time you have something, it'll just be one in, one out, basically. So you need to fill up the pool a little bit. Those are configurable. The high watermark, the amount of memory, I've just been using 1/3 of max memory, which I guess I don't have that computation here, but you can get it from android.runtime.maxmemory or something like that. I use 1/3, but it's just more of like, you can kind of tune it to whatever your app needs. I think I do high watermark at 1/3, and then the low is like maybe half of that, and then the GC threshold is, what am I using there? Oh, I'm using the same. So the GC threshold is just like when the cache knows it's evicted a certain amount of bytes, the GC threshold amount of bytes, it'll call system GC collect. That's just like ensuring that all of those bytes that it thinks are free are actually free. It's kind of unfortunate that you have to do that, but I found that without having that, you could still run into the OOM relatively easily. But that's all stuff to tune. Like, is it better to have more GCs that are smaller, or is it better to have one that's larger? It's up to you. But I think the comment here that I have is like, so your high watermark is where you want to be before you start evicting. The GC threshold is before you actually call system GC collect. So while you're evicting, some of that stuff's probably getting collected, but until the GC runs, then you know that all that memory's been freed up. So that's why I have that note. Like, so you have 1/3 of max memory is the high watermark, and then the threshold is also, I think, 1/3. Did I? I don't have that in here. It's in the sample app. So usually I set the high watermark and the GC threshold to be the same thing, which basically means you can have up to 2/3 of your max memory before the GC kicks in, because you could potentially have high watermark amount of bytes and then GC threshold amount of bytes that have been evicted but could still be sitting around. So you don't want to make the threshold too high. You want to make sure that the high watermark plus GC threshold is less than your max memory, because you want to kick the GC a little bit before you start getting too close to the max memory.
I was interested that you argued against using a relative layout, because as of a while ago, maybe a year or two ago, that was actually one of the suggestions from Google in terms from Android developers on how to speed up view layouts. And so I think
if you can use it if you're really careful. If you do it and you do it all in one view group, then it's good. Like if you do your whole layout and you have one relative layout and everything's inside of it, and you don't have any nested groups, then it's okay. But I think it's really easy to use it incorrectly.
When I'm doing a list view cell, I would usually have one relative layout.
Yeah, if you have that, and that's okay. But it's when you start adding, like, well, I need to have this, like, you have a relative layout, then maybe you want to have like a linear layout of things going this way, so you put a linear layout in there, and then once you start doing that is when it gets a little hairy. Relative layout's good for like fragment and activity layouts. I use those all the time. They're nice because you're not constantly, adding and changing properties on it, which causes the layout passes. If you use relative layout responsibly, I guess is all I'm saying. Anyone else? Okay, thanks.